This video we're going to have a quick look at polynomial equations. So a polynomial is defined as follows. So it looks a bit complicated there, but basically anything that looks like a quadratic, a linear equation is classed as a polynomial. Now in a polynomial, the first term, a to the power of n, cannot be equal to 0 because then we don't have x with the highest power. All the other a's in there, so a, n, all the way down to a0 are coefficients. They're just real numbers, and n also has to be positive. Now the degree of a polynomial is the highest power of x. Now common polynomials that you've seen before, just a constant, just a number, that is a polynomial. A linear equation is a polynomial with a highest degree of 1 because it's x to the power of 1. A quadratic, which has a degree of 2 because the highest power of 2. And then we've got cubic, which is the highest power of 3. And quartic, a highest power of 4. So all these actually come under the the heading of polynomials. Just got a few examples of questions here. Example 1, determine whether the values 3 and 2.5 are roots of the polynomial px equals x cubed minus 2x squared minus 5x plus 6. So to know if something's a root, it means when we put that value in as our x, our solution should be 0. Remember, our roots of the equation are the same as our x-intercepts, or they can also be called zeros. So we're wanting to know if we put 3 and 2.5 into this equation, do we get 0 as an answer? So let's try that and see. So we want p at 3 would equal 3 cubed minus 2 times 3 squared minus 5 times 3 plus 6. Put that into our calculator and we get 0 as an answer. Therefore 3 is a root. Now when we look at 2.5, we're going to do 2.5 cubed minus 2 times 2.5 squared minus 5 times 2.5 plus 6. When we do this, we get an answer of negative 3.375. Because it doesn't equal 0, 2.5 is not a root of the equation. And as I just said before, the zeros or roots of a polynomial are the solutions when the function equals 0, so they're the x-intercepts of the graph. Example 2, find the roots of the function negative 2x cubed minus 3x squared plus 2x plus 1. Going to go to our calculator and we'll solve this. So to find the roots here, there's two different ways you can do this on your calculator. I'm going to show you both. So the first one, we're going to go to the graphing page and we're going to put in our equations. Negative 2x cubed minus 3x squared plus 2x plus 1. Now from here, we can see from this graph that there are 3 x-intercepts, 1, 2, and 3. So to find these, we're going to go to Menu, Analyze Graph, and we go to this 0 here, because remember 0 means x-intercept and the roots of the equation. We have to do each one separately. So you'll see if I try and highlight all of them, it only picks up one at a time. So we have to do each one separately. So first one, negative 1.89. Next one, we can highlight that one, negative 0.355. And the last one is at 0.745. Now, if your calculator is not showing it to 3 significant figures, you can change the settings of this. So if you go to Menu Settings, you will see Display Digits Float 3. That means 3 significant figures. I would always recommend having it at least float 6, just so you can always see more when you're working with calculations for maybe next steps. And so there they are our 3 roots of the equation. Now another way you can do this is on the calculator page. And if you can go Menu, Algebra, Polynomial Twos, and find roots of a polynomial, which is just what we're trying to do. Degree means what's the highest power. In this one it is 3. Now we put in each value. So what's the value in front of the x cubed? It is negative 2. The value in front of the x squared is negative 3. In front of the x, it's 2. And the number on its own is 1. So you've got to put it in like that. Press OK, press Enter. And there you are. You can see there we have the 3 roots, which we also found on the graph side. Now you can choose either way to do it. I prefer the graph because I can actually see how many roots there are. So when it comes to some of the context questions you may not know, but a graph helps you visualize it. But you can use either method. And our answers to this one was when x equals negative 1.89 negative 0.355, or 0.745. Now remember, we always like to write our answers to three significant figures if we do have a decimal answer. So always make sure you're doing three significant figures. Example 3, find the x values for which the function equals 2x squared minus 3x plus 5 is equal to g of x equals x to the power of 4 minus 3x cubed minus 4. So we want to find the x values when these two are equal. There's different ways you can approach it, but we're going to use our calculator, which means because we want to find when they're equal, we want to find their intersection point. So we're going to go to the calculator, put these two in, find the intersection, and get our solution. To find the intersection, we're going to do this by graphing. So let's put these two equations in. So the first one, 2x squared minus 3x plus 5. Then press tab for the next equation, which is x to the power of 4 minus 3x cubed minus 4. We can't really see any intersection points, so we need to adjust our zoom. So once again, zoom out's a good one. Another good one I like to use sometimes is zoom fit. Doesn't help us in this situation. Another thing you can do with zoom is change the zoom settings, all right, to something that's going to work for you. So these are really big numbers, so I might just change them to say negative 50 and 50 and see what that looks like. Now I've changed it there, you can see, I can see two intersection points. So that's really important, and that's why graphing is great, because we can now see there are actually two intersection points. Menu, analyze graph, intersection, highlight each one separately, and we can see there our intersection points. So the x values is all we want for this question, so it'd be negative 1.60 and 3.53, both the three significant figures. And we only want the x value in this, remember, even though we had a coordinate in our answer, but the x would equal negative 1.60 or 3.53. Example 4, a diver jumps off a 10-meter high diving board into a pool. The height of the diver above the water is modelled by ht equals negative 1.2 t squared plus 1.4 t plus 10, where ht is the height above the water measured in meters and t is the time after the diver jumps in seconds. Find how much time passes after the jump before the diver enters the water. So because here we have height in meters above the water, so when the diver enters the water, that is when the height equals 0. So we're wanting to know when our function equals 0, which means we are finding the roots or the x-intercepts of the equation. So we're just going to go to our calculator to work that out now. For this one, we want to know when the equation equals 0. So let's put it in. So we want negative 1.2. Now this is t in this equation, but in our calculator we always have to use x and y. So please just be mindful of that. If you put in t, it's not going to like it, it's going to do something funny. So we've changed our t to x's, and we want to know when it equals 0. So our intercepts, you can see there's 2 there. So we're going to go find the zeros again, and we're going to find both of them. Now in this situation, remember, it's a context question, which means we want to know how many seconds after the diver jumps in. We can't have negative seconds, so ignore the first one. So our answer would just be the second one, which is 3.53 seconds to three significant figures. So as we found on the calculator, there was two solutions, which was negative 2.36 or 3.53. And as we just said before, because we are looking at a context question where we're looking at how many seconds, negative 2.36 isn't possible. So the time it took was 3.53 seconds. And that is the end of this video.